Good morning, good morning. Yeah, last night I kind of got stuck on this logic on how on parsing the compressed label in the DNS question, DNS messages question, and I couldn't sleep on it, and I wanted to have some progress on it before I start my day today. So I thought to start uh, uh, an ad hoc stream today. So yeah, uh, yesterday I figured out the logic I wanted needed to be inside this loop, right? So this condition out here doesn't make much sense because it only applies on the first byte that is parsing. However, the compression can also happen midway, which in this case is happening. I wanted to do a refactor here and maybe start with writing a parseLabel function which enables me to isolate the uh, label parsing logic. So maybe I can also use it recursively. I'm not still sure, but I'm going to try that. And for the input, I definitely need a buffer. Here I probably want to make it size agnostic, so even if everything is passed to it, it should be fine. And then I need an offset. And this offset is important, so every time I read some part, I need to uh, yeah, return it back. Uh, and the output would be a U8. Alright, and then I was thinking I can have almost the same logic while offset less buff blend and buff offset is not equal to 0. Uh, I can still do this. Save little links. Buff offset and offset. Max, right? And the return in the simplest form would be so here I want to have the start offset var equal to var let's say label start is equal to offset, and down here I will have label start up until offset. However, I still have a problem here, and that's the fact that a label could be a mix of a static portion and then a pointer portion, right? What can I do? Actually, I think it's simple. Zig and the string, I think plus mark also works here, or concatenation might be. No. Okay, zip guide. I think we will figure out, but here I want to have a var result of u8, which is undefined, right? And instead of a label start, I want to have, let's call it parser start, right? It would be the offset. And can I have result dot, no, plus equal? No, doesn't work probably. But that buffer, maybe that's what I actually needed. This one. No, is the guy the here the return type is just to the buffer, which I don't want to. Oh, that's a good one. Mem copy. Yeah. So for result parser in the size equals the result. Let's call it offset file. And then down here I want to do memcpy. Result from result offset to result offset plus label length. What you do is copying from buffer no part, let's call it label. Label start. Till label start. This would be offset. And then label start would be equal to offset as well. And result offset would also be equal to offset. Right, and then here return result. It's not the most beautiful thing, but I think it's kind of visible what we are doing, right? Now the only thing is parseLabel equal to if I have probably it's better to do it like this. Var label equal to u8 undefined if if buff offset is equal to 0xc0 label equal to parseLabel parseLabel. Here I can pass buffer to it again, and the offset should be buff offset +1, else label equal to buff label star tail offset. Right, hopefully, and then here we'll have label, no, label itself I want, and this kinda makes sense. So what I'm trying to do is, in a loop, I read it part by part. That was the logic I initially had, but so far I was just checking for the length and jumping that much and ending up with the last offset. Then at the end I only read the part I needed, but there was a problem with that I couldn't distinguish the compressed label parse. But now what I do every time I'm starting with the first byte of a label part, I check if it's a compressed message. So we have the compressed pointer. If that's the case, I rerun the logic parseLabel based off the pointer offset. If not, I read to that. And if the pointer offset is happening, it's going to read the whole thing up until the byte 0, which makes sense, hopefully. The thing is, I hope that it's not like one part is compressed and the next part is not, because then I won't see the 0 byte until I've read everything. But let's try that. And I don't think this is going to compile because apparently I need the allocator here, which I'm going to figure out. I intentionally didn't write that part. So with that being said, I think I need, okay, here another thing needs to be returned. Apart from the U8 size, I need the offset. Yeah, so maybe we do struct label U8 offset U size, and then down here I need to return dot label equal to result dot offset equal to result offset, right? And then here I remove this whole thing. Const labels equal to the deconstruct. Can have this struct one day. Okay, so can I have const label offset parseLabel buff offset? Okay, and then no, I don't want the offset to be constant. Oh, that's why. Okay, that's why it's white. Okay, and then here, actually, let's rename this to name. Also, rename this to name. for the raw byte. I'm not getting any special detail out of it. So let's just start from the beginning of the thing. Okay, let's see how it goes. Not assigned to a constant. Where am I assigning it? Line 18. Okay, yeah, that's true. I'm going to make a copy of it, call it parseLabel offset, use size equal to offset. And here I'm going to dot rename, call it label offset. No, for you, I want it to be, and then offset. So now I have a result offset, a label offset. It's a bit ugly, but yeah. Interesting. Cannot I recursively call my function? This is not fun. Expected type U8 found parseLabel struct. Oh no, that's okay. No, I can call it, but here I want to have this. How about the offset? I don't care about that, right? Label offset is that. The only thing is I'm not just need to move label offset a little bit. I'm still not sure. I'm kinda lost in between this different type of offset I'm tracking. Parse-label buffer. Okay, you cannot destruct it. Down here I would call this parse label equal to this. Name would be equal to parseLabel.name. Actually, and then parseLabel +1. Incompatible types, message questions, right? And com type int, parseLabel, yeah, here I meant offset. Compiled. Okay, now I do this, it crashes again. Core dump, memcpy. Source and destination are not the same size. That's a very good point. I didn't check for that. So I do this, and then actually I need more. And then here I want result offset, label length, and label dot length. I also want to print the label itself. Make sure the label is ABC, which is this one. Label length is C, okay. Then it should be okay. Yeah. Here we are reading the length. So label start should be this, right? And label offset. Are we increasing it? Hopefully, yes. That got corrected. Now general execution, src, what's happening? General protection exception, no address available, source 0-0. Again, it's still here. Is it because of the size of the thing? believe it is. Var result. The error is a little bit cryptic. General protection exception, no address available. SRC0 is the 0 bit of this label. Then why is it saying that it's not available? Okay, I'm going to ask GPT about it. What's wrong with this piece? Can it figure it out? Several issues with this code. Nice. Result is undefined, but never allocate memory for it. When you try to copy into it, you are trying to write in an uninitialized memory. Correct. Offset calculation, the line overwrites the result offset. Okay. When handling compressed labels, you increment label offset by 1. Okay. Lengths mismatch. Label length bytes, but the actual. You need to allocate memory for result or pass in a buffer. Fix the offset tracking, handle compress use. That's the point. So this is the error I'm currently facing, hopefully. Right, result is undefined. You declare this, but never allocate memory for it. When you try to copy into result offset, you're writing an uninitialized. Okay. Give me please. I want to see how that works. So it's taking an allocator of an array list. Okay. But it's doing the DNS up here. Current offset, first jump. Yeah, these are better names definitely than mine. First jump, final offset. For dynamic result buffer allocation. And then you do append, which is nice. Current offset, first jump true. Okay, the thing is that it's not recursive anymore. Let's see. Check for compression pointer, right, in the while loop. What it does, if label lengths okay, this is weird. Why do the compression like this? It's ending them, it makes sense, but why? If the current offset +1 bigger than equal to buffer len break, save the position after the pointer for final offset. If first jump pointer for final offset, jump to the pointed location, So now we are doing an AND operation on every byte of the label length except for the first for every bit of the label length. We have 2 bytes, right? For every bit we are doing it except for the most significant 2 bits which are used for the compression pointer, right? We are handing them together and then read the 8 bit and ORing them current offset +1. Okay, these two I need to get an explanation on how they work, and then current offset is equal to pointer. We continue when this happens. So we jump out of the loop. The thing is, here it's extracting the offsets, but I don't see the label being read. Then regular label so +1 plus label length if result items So add dot separator if not parseLabel. Okay. Copy the label. Skip the null parameter if we haven't jumped. Okay, that's interesting. Answer the following. Why are you using to check for the comparison indicator and not simply okay, what is again? Wait a minute. Here is doing 0 is equal, and then the same for the pointer location. Then how are you reading the compress label? And right now it's I think I understood this one. Let me explain it first myself and then ask the LLM. So what's happening here is that it's figuring out the offsets, but it continues, goes up here, right? And then starts from here. That's why. So the reading logic is unified. It's just the offset calculation that takes a different path. But how does it guarantee to get back to initial offset if first jump, final offset? Okay. We have a current offset. Now I need an explanation, I think. Let's do this. Chess Deviant is asking what is a DNS server. DNS server is basically what internet is using to translate IP addresses to the domain names. So every time we put google.com, for example, let's see, over here, every time we put google.com in our browser, it needs to connect to this computer IP address, and this translation is happening via a DNS server. If you don't know it, probably your ISP is configuring it for you. But there are other options to use, like Google's DNS or one of my favorites from Cloudflare. Yeah, that's that. But the answer, great questions. Let me explain the DNS compression format. Why this instead of this? In DNS compression, the top 2 bits indicate the type. So label lengths could be okay. The mask extracts just my pleasure, Jess. The mask extracts just those 2 blocks. Okay. Okay, now I learn it. It's okay. And then what about this? A compression pointer is a 14-bit offset. I'm a fresher DevOps engineer. How long do you think it will take me to learn about my job? And give me tips, thanks. Yeah, how long, to be honest, depends on how much work are you going to put on it. The best tip that I can give you is to just if you want to learn about this concept, is to just bring up a web server and yeah, try to configure it yourself. Buy a domain, create, I don't know, a blog, and try to serve it yourself. And then you see the challenges, and you gradually learn about how you can optimize your workflow. I initially back then, it's like 20 years ago, wanted to create a blog for myself. I was buying a web host from a provider, and they were giving us this cPanel, which was a control panel for domain configuration, and you were putting IP addresses here and there. And then from there, I moved on to my own VPS, and then Cloud King kicked in, deployed my servers over Lambda functions, and now I'm back again serving my own websites. And so I have an understanding of how DNS servers work, right? But I've never developed one for myself, and that's basically what I'm doing today, going down to the stack, not just using the tool. I'm trying to teach myself more about these details. But for sure, these details are not necessary if the goal is doing the ops engineering. There, I think setting up services would be way more helpful to you than writing a DNS server for yourself. Yeah, I think that's it. Yeah, why label lengths instead? Yeah, these 2 I read. Compression port there is 14-bit. Yeah, the first top 2 bit I don't want it. And then here we are extracting the least significant reading. Thanks, Jess, my pleasure. Reading 8 byte, and then here adds the low 8 bits. This I don't get, right? I understand that we are extracting the lower bits out of the chunk, right? But we are ORing them. Ah, okay, the pointer. Now I get it. The pointer, so let's say we have probably better to do it with zeros. So these are the first two bytes that we have, right? The first two bytes of each part. These two indicate if it's a pointer or not. The rest from here to here can be the address, and that was the part I was missing. I was just considering these as an address. So now what this is doing is extracting this piece regardless of the value of these, so making sure these two are set to 0, so no error there. Extracting this piece and adding them together with this to come up with the pointer. Okay, now I got it. Okay, now how am I reading the compressed label? I'm not reading the compressed label directly. Instead, extract 14-bit pointer value, set the current offset to pointer to jump to the location, continue for parsing from the new location. The actual label data is read from wherever the pointer points to. This handles the recursive nature of the DNS compression. A pointer tells you where to continue reading the actual label. So when you finish reading the compressed label, does it also indicate where to go back to? I don't think so. No, DNS compression doesn't automatically tell you where to go back. You have to track it yourself. That's why I use first jump flag and final offset variable. Before jumping, say where we should continue parsing after this label. Jump to the compressed data, follow the pointer and read the actual label bytes. After reading, don't go back automatically. We are done with this label. Return the saved position so the caller knows. Ah, okay. So every time you are reading one piece of the total name, complete name, then its name is structured like that. Okay, let's see how this works. I'm going to just copy this because I don't have much time to write it myself, but definitely I'm going to dig deeper on it. I'm still not sure if it works. for one. There is no first jump and expected 3 arguments. Yes, I need an allocator. parseLabel. Yeah, there is no init for this. It should be like std array list u8 No, it's not unused. I have a try somewhere here. Try. Also here, allocator. Do I have another one? Result up in the slice. Yeah. U3 cannot. Okay, I think I'm going to get back to this. I couldn't finish it in this session either, but it was really interesting. I was missing a few crucial points on the compression logic. I'm still not sure if I get it myself and I kind of write it myself, so I need to spend some more time on it. But yeah, that's it. Thanks for watching. I hope you also learned something from this session. Let me know in the comments what you think about it. See you later and have a nice day.